Hello, welcome to the unit on density. This unit follows chapter 12 out of the HEC text. It is also chapter 11 out of the OpenStax text. So begin with a question. Here I have 6 pictures. What's the same? What's different? Well, different is pretty obvious. It's all different sizes. It's all different shapes. But what's the same? Well, it's all the same color. And hopefully you pick up on the fact that not only is it all the same color, it's all copper. It's all copper. Okay, what else does that mean? The fact that it's all copper, even though it has different mass and different volume. Well, one thing that is true is because it's copper, it all has the same density. Density is a property that's inherent to every substance. And you can use density to identify the substance. By definition, density, that's what this little guy here means. That is the Greek letter rho. It's like a little curly P, if you will, is the mass of the object divided by the volume. Units you may see for density include kilogram per meter cubed. That is the standard SI unit. But you also might see it in grams per milliliter, like on the next slide, or you might see grams per centimeter cubed. Okay. Lots of different possible units for density. One common error students make is that they forget to worry about the units. And what they say is the density of water is 1, which is true if you're in the correct unit. It's 1 gram per centimeter cubed, but it's actually 1,000 kilograms per meter cubed. So watch your units here. Here is a table of densities from the OpenStax text. You can see the units above. So if you're in kilogram per meter cubed, you have to take all of these numbers and multiply by 10 to the 3 or 1,000. If you're in gram per milliliter, you can just take the numbers as they're written. There is a different version of this table in the OpenStax text, and you may have to refer to one of the tables to do the calculations that you need to do. On a quiz or an exam, I will either ask you to do the calculation or I will give you this number. I'm not expecting you to memorize the density of, say, ethyl alcohol. Okay. So, a similar question. What weighs more, a ton of feathers or a ton of bricks? There is multiple variations on this question. I like this one. We'll go with it. So what weighs more? Well, look. Both of them weigh the ton. So their weight is the same. But, okay, my feathers have a low density as compared to my bricks, which have a high density. And we have a ton of each, so you can see our lovely balance beam here is balanced. So our mass is the same because we have the same weight. Okay, but if the mass is the same and the densities are different, that's going to require a different volume. So our low density is going to have a large volume, and our high density will have a small volume. Okay. So now let's do an example calculation. We're actually going to use this example calculation to identify a substance. So we're told this substance has a mass of 2,088 kilograms. And we are told the volume it takes, so we can find the density by taking the mass and dividing by the volume. Okay, so we take 2088 kilograms and divide by 2.4 meters cubed, and that gives us a density of 870 kilograms per meter cubed. But remember that table we saw is in these units, it's often written times 10 to the third kilogram per meter cubed. Okay, now if we go back to that table of densities and we start looking, there's nothing here that is 0.87, at least nothing specific. We do see wood has something in that ballpark. Okay. Gasoline, olive oil. What is this? Okay, here's the problem. This substance isn't found in that table. You have to look at the table in Unit 12 of HECT to find out that this is turpentine. Turpentine, by definition, has a density of 0.87 times 10 to the third kilogram per meter cubed. Okay, one last concept for this unit, which is why it's all one video, and that is that the specific gravity. So the specific gravity, by definition, is the density of your substance divided by the density of a standard. Okay, density of a standard. The standard varies. For liquids and solids, the water density of water at 4 degrees Celsius is often used, and that is the so density of water at 4 degrees Celsius, that was the 1 gram per centimeter cubed, or 1,000 kilograms per meter cubed. If you're dealing with a gas, the standard is often the density of air. Okay. And again, I will specify exactly what I want to use, or what I want you to use for the standard when you do these calculations. Notice that this is a ratio, so it is a unitless quantity, which is actually kind of nice. Okay, so let's do one example here. We're told the specific gravity of copper is 8.96. And we want to know what the volume of 6 grams is. So this is the rho of our density of our substance divided by the density of the standard. The density of the substance, I don't know, but I do know for this solid copper, the density of the standard is going to be the 1 gram per centimeter cubed, density of water at 4 degrees Celsius. Okay. I chose that version of the standard units because I know my number up here is in grams, so it makes sense to match my units. Okay, rearranging, I can write that the density of the substance is going to be the specific gravity, 8.96, times the density of the standard, 1 gram per centimeter cubed. So that gives my copper density at 8.96 grams per centimeter cubed. Thus why that standard is chosen. It makes it very easy. I also know that density is mass divided by volume. Rearranging gives that volume is mass divided by density. My mass is 6 grams. My density is 8.96 times 10, grams per centimeter cubed. I got going with the times 10 to the third there, wrong units. So 6 divided by 8.96 is 0.67 centimeters cubed. Okay. There is more to the chapter 12 in the HEC text than what is covered in this video, but we are not covering that in this class.